Hey guys, this is Karan and this is the objective part 2. Okay, so on objective part 2 we're going to discuss many things. So here's the preview or content again. Heat transfer. Well, there's three things in heat transfer: conduction, convection, radiation, and then we are going to talk about sensible heat, then latent heat, and then formulas, and of course when there's formulas we have examples. Okay, so to start off with heat transfer, in this process we are going to talk about three different processes in which heat of transfer of heat from one system or substance into another is accomplished. Okay, so on how it's processed. Okay, we're going to go deep into how it's processed in moving from one system to another system, or one substance or another substance. So the first thing that comes up is conduction. Some of the people might heard this word, but some of the people didn't. Okay, so what is it? Conduction. Well, conduction is when it occurs in solid. Okay, so conduction always occurs in solid substance, though it can in liquid or gases in more limited fusion. Okay, fusion is in latent heat, and we will get to that. But what happens is that the atoms of the atoms or the molecules vibrate anyway. Okay, they vibrate anyway. This vibration contributes to the temperature of a substance, and this vibration, now what happens is that in conduction, when the vibration by atoms and molecules happen, so the vibration that happens contributes to the temperature of substance. Okay. Now what happens is that the manner then lead to the transfer from one molecule to next. So that makes in solid objects to move to one system to another, or one substance to another, because of the particles moving. Okay, atoms or molecules moving. When it's moving in a solid object, okay, when it's moving, okay, the transfer happens. Though it can happen in liquid or gases, but it's when there's limited fusion. Okay. Convection. So the second part is convection, and the summary of convection is really easy. When things are heated, they expand. That's it. Okay. When things are being heated, they expand. Okay. The expansion causes the density to decrease. Okay. So when there is expansion in something, that something or that substance loses the density as well. So what happens is that in this case, liquid and gases together are called fluids. Okay, they float in the layer based on particularly on the density. So what they do is float on the upper layer where there is density. Okay, it's not the upper layer, but where there's density, which is basically up. That is why upper layer. Okay, thus after talking all this on convection, I got better things to tell you. Okay, just remember this. Okay, when there is less dense fluid, okay, on the top, that means is okay. How do you do this? That means that if you have less dense fluid rising up, okay, it's actually more dense. Okay, it's more density. It's more dense. Okay, when it's rising up. But when it's rising, when it has more density, okay, it's rising, going down. Okay. Now this might seem confusing. Okay, but when you have substance with less density, it's gonna rise up. Okay, that's as simple as that. And what's the opposite of it? Well, if a substance has high density, it's gonna sink. That's basically it in convection. So that is why the transfer happen up and down, but from one system to another. Now some people might have heard radiation, nuclear radiation and things like that. So I'm going to teach you how the heat transfer happens. So now that we talked about conduction and convection, both require some movements, right? Some movements of physical substance of transferring energy. Okay, they need physical movement. Okay, in this energy, in radiation, the energy is transferred by electromagnetic waves. Okay, the waves it sends, that is how the energy is transferred. Okay, and that's basically it on conduction, convection, and radiation. And now that sensible heat. So sensible heat is when heat causes in temperature of substance. Okay, when heat causes the temperature of substance, that's basically sensible heat. The latent heat is used in phase change. When you have phase change, it's latent heat. So latent basically in Latin means hidden heat. Hidden. Okay. Now we go to formula. Let me erase the board. And if you remember what I said from the objective 1, there's 2 charts and I discussed about 1 chart. Well, right now I'm going to discuss about second one, which gives, second one basically gives the boiling point, latent heat, the fusion heat. Fusion basically is the latent heat, then it gives you sensible heat. Okay, so the formula for the sensible, I should say, how to calculate the heat with latent heat or sensible heat, it's basically Q, as you might have guessed it, because we are calculating the heat. And the best thing about this is we can predict how much heat we are going to use, how much energy we are going to use. Okay, I'll show you in one of the examples. Okay, so mass of a sample times the latent heat, and here we have 2 heats, LF, which is latent fusion, and LV. Okay, vaporization. V stands for vaporization, F stands for fusion. Okay, latent fusion. Okay, and there's latent heat. Okay, then this is the mass of a substance sample, and this is the heat how we get. That's basically it. Knowing this, let's go ahead and remember, guys, this is the core part of physics. Okay, so if you don't understand, message me. I can do this again with going over the materials or the part that you didn't get. Okay, or you can just rewind the video and watch it. The first question goes like this: how much energy is required to boil 2 kg of water to steam? So again, like I told you, we can predict. So now we are predicting how much energy is required to make the water, the mass of the water, into steam. Okay, water and steam is 2 different substances. Okay, when water is there, you can drink it. When steam is there, it's vaporized. Okay, so since we're converting it to steam, which is vaporization, we use vaporization. Now the mass which was given was 2 kg of water, and when you take the vaporization latent heat for water, it's a big number, so I'm not going to bother to write in brackets. Okay, and that's just unit. But when you multiply this number by this, you should be getting 4, 5. So this is how much energy that it's going to occupy or take. It's going to take 4,544,000 joules of energy. Okay. So this was an example for me to solve. Now it's an example for you guys. So the example basically, like before in previous section, we talked about momentum, and it involves everything we learned before. Okay, so I took one example which takes everything before, which is in objective 1 and in objective 2, which is basically this. Okay, so the question goes like this, and if you don't understand, please wait, let me solve the example, and then if you get it, that's good for you, because all we are doing is learning here. Okay, 1.16 kg of a 1.16 kg chunk of heat at 20 degrees Celsius is heated to its melting point. Okay, and then completely mental. Okay, what happens is it's heated to its melting point and then it's completely melted. Okay, how much energy does it require? So since we do things that we did in objective 1, now that we are finding heat, we know that heat is mass times Celsius times change in temperature. Okay, the mass which was given is 1.16 kg, and in the example or in the chart, the Celsius and change in temperature should be given. Change in temperature is basically in the question, which is 322 final minus initial. Final temperature is 322. $328 minus 20. Okay, and if you multiply this, you should be getting 46446.4 joule. Now, that's how much the heat of the metal is, the substance we are using here, which is the chunk of a lead. Okay, and now we are finding the latent heat. Okay, we know that this is equal to some amount of heat. Okay, so this is what we replace with the Q here. Now I know that. How much is this? So we know that Q is equal to mass times fusion heat, because we are fusioning it. And then we found the heat to be it's the last step. Okay, my bad. So you have mass is 1.16 times the fusion heat, which you will find it in the chart, which is 23000. Okay, and then after you're done, you'll find that the heat is 26680 joules. And you take the first heat, which is the sensible heat, and you add it with the fusion heat here, and you have 26 for now that we have found out the heat of this substance. Okay, and it's basically the latent heat after all we find it, and it's fusion here and it's latent heat. Okay, remember that. Okay, so we found the sensible heat to be, you add latent heat plus the sensible heat, you get the total heat. Okay, so you add this number by the sensible heat, and if you add that number, you should be getting total. And when you add these numbers, which we found out, you should be getting the total to be 73126 joules, or you can write it as 73.1 kilojoules. So it's basically how much energy it requires for it to melt completely of the chunk of lead. Okay, it takes that much energy to melt completely the chunk of lead. And again, if you understand the objective 2, please If you like my video, please go ahead, subscribe, like my video, so I know that you really like my video. Please go ahead and give me a feedback so I can do more examples, and also message me for your names. Give me your names and I'll put your names into example. But before messaging me, please go ahead and subscribe, like my video, favorite it to your YouTube account. Thank you.